Okay, a little demo here on solving right triangles, which I started in class. I gave you a couple examples, but I want to follow it up here with a video. So two types of solving triangles problems you're going to have here. One is going to give you a side and an angle, like the first problem here. Solving a triangle means you have to find everything you don't know about this, all sides, all angles. So in this first problem, we got to find out what AB is, what AC is, and what the measure of angle A is. Easiest thing to find here is the measure of angle A, because all three angles have to add up to 180, and we know two of them, so we're just going to do a simple subtraction from 180, and we're going to find out that this is a 63-degree angle. Then we're done with that. We're not going to use that. We're only going to use the given information here. So what I'm going to do to find out what side AB is over here, since from the given angle of 27, that's the opposite, and 7 there is the adjacent, we're going to write the equation that the tangent of 27 degrees is the opposite over the adjacent. Solving this is going to just be simple algebra. So 7 times the tangent of 27. All right, so the 7 times our tangent of 27 is equal to 3.57 about. So we have AB is about 3.57. We're going to do a similar thing for side AC. Here, AC is the hypotenuse. So 7 the adjacent, AC the hypotenuse. That's going to be an equation of cosine of 27 is equal to 7 over AC. When we arrange this differently, we're going to get AC is equal to 7 divided by the cosine of 27, which is 7.86, approximately. So that triangle is solved. Down here we got a different one. This time you don't have an angle. We have a third side. So here, let's separate this here. We've got to do Pythagorean theorem. So DE squared plus 16 squared equals 20 squared. I'll let you do that. And you're going to figure out that we are going to get 12. Okay, so of the three things that I have to find on this triangle, which I forgot to outline here already for us, we got to figure out what DE is, and we just found that. We got to figure out what the measure of angle D is, and what the measure of angle F is. So we have the 12 here. Okay, that's our first thing that we're going to find. So now for the measure of angle D. From D, 16 is the opposite, and 20 is your hypotenuse. So we're going to say that the sine of D is 16 over 20. This is an inverse. This is how you do inverse. This is why you do inverse. You don't know the angle, but you know that sine is equal to 16 over 20. So the angle whose sine is 16 over 20, we type in just simply sine inverse of 16 over 20. Make sure you're in degree mode for that, or it ain't going to work. Approximately 53.13 degrees. So that's what the measure of angle D is here. Now, I don't want you to use that. I want you to try and find the other angle F using sine, cosine, tangent also. So from F, 16 is your adjacent and 20 is your hypotenuse. That gives us cosine of F equals adjacent over hypotenuse. And you guessed it, measure of angle F is going to be found by doing the cosine inverse of 16 over 20, which is about 36.87 degrees. Okay. So that's everything you got to know about solving right triangles. They're all going to look like either this one where I give you the right angle, an angle and a side, or this one where I give you the right angle and two sides. Every single solving the triangle problem will look like those. A word problem here using some of that stuff. Safety regulations say that the maximum angle of elevation for a rescue ladder on a fire truck is 72 degrees. So we're going to draw a simple right triangle picture out of this. Here's the fire truck over here. Here's the ladder right there. So the maximum angle of elevation is 72 degrees. If the ladder, which is this part right here, is 110 feet long, how far up can the ladder reach? So this, if I call that x, I need to look at this and say, well, from the 72, that's my opposite, this is my hypotenuse, so I say the sine of 72 is x over 110. So I'm going to solve this doing just 110 times the sine of 72. Make sure again you're in degree mode. So approximately 104.62 feet. Now in the real world, we would have to take that and we'd have to add that to the height of the truck, but this problem didn't provide that. But be mindful of that nonetheless. Our last thing here is simple harmonic motion. We have a description here that if you have a basic sine or cosine behavior, it could be waves in the ocean, it could be, as we're going to see here in a short while, a spring bouncing up and down. A point that's moving up and down, say the waves in the ocean were always the same, and yet a buoy tied down out there, well, that buoy is going to go up, it's going to go down, it's going to go up, it's going to go down. So it's going to be shifting just like a sine or a cosine graph would be. So they give some guidelines here that say basic or simple harmonic motion can be denoted by one of these two equations. D equals the sine of, I'll call that W times T, or D equals A times the cosine of WT. And here's what those things represent. A, we know that's our amplitude, which is the displacement from the equilibrium, how far it goes up and how far it goes down from the zero line. The period is going to be 2 pi divided by W, W being whatever number that is right there. That's the time that it takes for one full cycle to complete. And the frequency, the number of cycles that it's going to complete in 1 second, is going to be the reciprocal of that. W divided by 2 pi. So let's take a look at an example here for this. So here is a book example. A spring with a ball on the end of it. I'll call it Rudolph's nose here. When it's at rest, it hangs right here, as the first picture shows. That's what we're going to call the equilibrium. Now, if I pull that spring down a distance of 10 centimeters over here, and I'm showing you that right here, the ball has been pulled down 10 centimeters from where it started, and I let go of it. If there's no friction or no air resistance or anything like that, it's going to go up to a height of 10 centimeters also, and that should continue forever, theoretically, even though it really would not in the real world. So what we're going to have you do is find the following things here. Oh, and by the way, this is a 4-second cycle. So from the time I let go of this thing, the time it goes up and comes back down to the bottom is 4 seconds. So the period is going to be 4. That's exactly what the period means. How long does it take for it to complete one full cycle? The amplitude, how far does this thing shift from, if this was a graph, we have this dotted line here, how long does it, or how far does it go above and below that? That's our amplitude. Well, we can see that it's a 10 centimeter up and down. So our amplitude is 10. What about the frequency? How many cycles does it do in a second? Well, if it takes 4 seconds for one cycle, as we see at the top here, 4 seconds for one cycle equates to 1/4 of a cycle in 1 second. And then last is our equation. What's the equation going to be? Well, when this thing is at rest, it's on its equilibrium line. That's what happens with a sine function. A cosine function starts up at 1. So we know that this is going to be an equation of the form D equals A times the sine of W times T. Now, things we already know about this is we already know that the amplitude is 10. So we now have to look at what about the W value in there. Well, that's demonstrated, or that's determined by the period. So if we look up here, we already know that the period is 4. Look back on the previous slide here. What did I tell you about period? It's equal to 2 pi divided by the W value. So I'm going to set those two things equal. 2 pi over W. 2 pi over W is equal to the period, which is going to be 4. So if I rearrange this, and I solve this for W, I get 2 pi divided by 4, which is pi over 2. So that guy is what goes in that parentheses in front of the t. So pi over 2 times t. I should point out, I know before we said that the frequency here is 1/4. Let me point out something here. That the frequency is the reciprocal of this guy here. So if I set W over 2 pi, if I set that equal to what I got for frequency, W should come out to be pi over 2 here. So W is going to equal, let's raise that up here, multiply both sides times 2 pi, so 2 pi over 1 times 1 over 4. Sure enough, it does simplify to pi over 2. Just a little bonus piece of information there, just so you can see that it's all consistent with what we're telling you here. Okay, that's a lot of information in 11 minutes. I'm going to give you guys some problems here to do on page 326. On page 326, I want you to do numbers 3 through 8. Do all of those. We'll look at numbers 17 and 18, 22 and 23, and then we'll see some of the harmonic type problems in 55 through 58. Good luck on those. We'll talk